Good morning, everyone. Thanks for joining me this morning for this quick presentation. My name is Christie Rowzee. I am the Regional Sales Consultant for Control Bionics. I live in New Jersey, but I cover the Northeast Territory. What I'm going to be showing to you guys today is the NeuroNode, which I have on my wrist right here. And what the NeuroNode is it acts as a wearable switch. It can be placed on any part of the body that registers voluntary movement. And from that movement, we're able to create a switch activation site for the user's communication device or computer, AT system in the classroom. We also work with adults as well. So I will be explaining the NeuroNode to you and some of its capabilities, specifically in the classroom and with your students. So what we say about the NeuroNode is that when we created it, we wanted it to be simple, reliable, flexible, and fun for clinicians and caregivers, but also for our users, and used for a variety of platforms, situations, and conditions. As I mentioned before, at the heart of the Control Bionics product line is the NeuroNode 3.0. I have it right here on my wrist, and I'll also have pictures and kind of show it to you guys in action. But we have found that it has been really a game changer for students who struggle with traditional switch access methods because it's placed directly on the user, as well as customizing how much movement is required in order for the user to create a switch site. So we see increase in communication, reduced fatigue, and increased accuracy, and as well as participation in the classroom. So we say that this is a switch that can move with the user. Since it's placed on the body, if the student is being repositioned, being moved around in maybe their wheelchair, you don't have to change the positioning of the switch if it might be mounted onto the wheelchair, because it is on them, so it moves with them. We've noticed significantly lower fatigue over the course of the school day. This is reported by teachers, caregivers, and the users themselves. You have cross-platform abilities for hardware and software, which I'll talk about. We provide two system offerings. One is a Windows-based system, and the other is an Apple-based system. And we also have compatibility with different communication softwares as well. This is an AT solution that doesn't limit the student's ability to interact with the caregivers and the peers. So who can use the NeuroNode? Those who are struggling with low-tech access methods, maybe they want something a little bit more advanced. The students who find their current assistive technology solution exhausting or fatiguing. And our target population are going to be those individuals diagnosed with conditions such as SMA, cerebral palsy, traumatic brain injury, anything that's going to inhibit physical access to either their communication system or their computer for classroom participation. So here are some of the key features of the NeuroNode, and then we'll go into a little bit more specific about how it works, and I'll demonstrate it for you in live time. So the NeuroNode itself has a 24-hour active battery life, so you're not going to run out of battery throughout the day as long as you have it charged overnight. It's very small and compact. It can be very discreet as well, as you can wear it underneath clothing. You have two methods for how we register movement. One is spatial and the other is EMG or electromyography. It's very durable. We have improved kind of the casing that it is in so that it can survive the school day and work with a variety of individuals of different ages. It is iOS and Windows compatible. And when it is completely dead, we see less than a 1-hour charge time. So it really does not take long to charge if we are out of battery. So here is everything that would come if your student were to get a NeuroNode. So we have the NeuroNode itself, the NeuroNode controller application, which is how we measure how much movement we need in order to create a switch, which I'll show you guys in a bit. The electrode kit, which is how it can attach to the user if we're not using our band. You get the Neuro band, which is our popular option. The lead wire adapter base, this is how we connect the NeuroNode to the electrodes themselves, if we would want to put it on a more specific muscle site. And then you get your charger kit, which it's just a little portable charger base that the NeuroNode sits on top of so that it can charge. As far as attachment to the body goes, we say how it is placed on the user is completely customizable. Our most popular option is this band that I'm wearing here. The band comes in 2 sizes. And then we also have the electrodes here. We have singles, we have triples, which the NeuroNode can snap into if we would want to put it on top of a shoulder or a calf. And then we also have our Neotechs, which go on top of the face and are used for placement sites that are maybe more sensitive to the skin. I did just see the chat about school districts paying for this. We do work with school districts across the country, and we have had some districts that pay for the NeuroNode system and the communication device as well. We also are fundable through insurance, Medicare in all 50 states. We're fundable through New Jersey and Pennsylvania Medicaid, as well as private insurance funding. So I'll talk a little bit about how it reads the movement and how we're able to create a switch site. So our EMG mode, or electromyography, what it does is it registers the electrical impulse the brain sends to the muscle upon activation. The EMG signal is displayed as a graph on our controller application, and you can modify the threshold parameters based upon the user's activation level. So how much movement is needed in order to create this switch site, again, is completely customizable based upon the user and their individual movement. The best thing about EMG is that it can detect really small movements to eliminate potential fatigue. Our EMG technology can register movements that are actually naked to the visible eye, so can be really good for those students who have progressive muscle conditions like an SMA, where maybe there's not a whole lot of active movement that they have a lot of control over. And the other thing that's really interesting is that if we can start picking up these small movements and it's less movement that's required throughout the day, then we start to see over time a reduction in fatigue than with traditional external switches like jelly beans and things like that. So here's a couple of common placement sites when talking about where the NeuroNode can go and what movement do we need to create a switch. I see I have some questions here. I'll talk about the price at the end when I'm going through our 2 system offerings, and then it can pick up a muscle contraction if you don't see actual movement, potentially yes. That's kind of what is at the heart of the EMG mode. I've worked with individuals who we put the NeuroNode on them. They say that they're moving. I don't really see active movement on them, not a whole lot. Maybe if I put my hand on the muscle site, I can kind of feel a contraction, but we're able to detect changes on our graph, and from that way, we're able to pick up and create a switch site from that movement. Yes, we've seen that with lots of different users. So one of the placement sites is that I am actually going to demonstrate is right here on my forearm, and it can pick up finger flexion and wrist flexion. If we move a little bit further down the forearm, then we would pick up a ring finger flexion. Face is very popular for our adults, specifically maybe an adult with ALS, if they're more at the late stage. Eyebrow raise or smiling are 2 really common placement sites. We would just put the electrodes on the forehead or the electrodes on the smile line. So as an example, if you guys can see me, here's the electrodes. We would just put the electrodes on the forehead right here and pick up an eyebrow raise as the switch activation site, which is why this little lead wire adapter base is important. You can also put it along the thigh for a leg adduction or abduction, or we could put it along the shin or the calf if we wanted to do a toe point or a heel raise. A little bit about placement of the NeuroNode. So on the NeuroNode itself, we have 2 active electrodes and then a grounding electrode. This is kind of how we do the reading of the EMG signal. I'll take off the NeuroNode on myself and put it a little bit closer to the camera if you guys can see. But there's these 2 dimples right here. You can feel them. If I turn it over, these are my active electrodes and this one's my grounding. So when we think about EMG, we want to put the NeuroNode on the muscle that's going to be doing the actual contraction, not necessarily on the part that you see moving, depending upon what that is. So if I'm doing, again, a finger flexion, the muscle that's controlling my finger moving is right here. So I would want to put the NeuroNode right along the length of the muscle to pick up that contraction. We're not necessarily going to want to put it on the finger because we're not going to pick up the EMG or the electrical impulse. If we're talking about an eyebrow raise or a smile, these muscles are directly related to what you see moving. So we would put, like I had showed you guys before, the electrodes directly on the forehead to pick up that movement. So we kind of have a couple of ways that you can look to see how to put the NeuroNode on the body to make sure that you're getting a good placement site and a good reading with that. See, I have a question. Okay, so if we look at these little pictures here, this would be an example of using the NeuroNode with the neuroband. Again, we have the NeuroNode right along the length of the muscle if we're going to target a finger flexion. If we look on the leg placement, those 2 little dimples or notches are not along the length of the muscle, so we would not be getting a good reading from that placement site. The best thing I say to do when we're trying to figure out where it should go is really put your hands on the student or the user and feel what's contracting when they're making that movement, and that'll kind of help with the placement of the actual NeuroNode itself. And here's another example if we were using single use of electrodes versus a whole NeuroNode and band. So we want our 2 active along the length of the muscle, and the grounding is going to be kind of on a little bony prominence on the wrist. Then if we look on the leg here, you'll notice the 2 active electrodes are not along the length of the muscle, and the grounding is not placed on bone. So we would not be getting a good signal from that placement. So now what I'll talk about and demonstrate, so you can kind of see it all together, is what it looks like on our controller application. And this is how we create a switch. This is how it all comes together for the user, and we can really customize it to them. So this is what our controller application looks like. That blue line is the actual EMG signal. So there's changes there as they go to make their movement or muscle contraction. You see there's a green line at the top and a yellow line at the bottom. Those are our thresholds that we are going to modify to create a switch. So again, these thresholds are completely customizable. We can put them as high or as low as we want. If we look here, these are some little quick buttons at the bottom of the application. So we have our main menu. You can save the settings, which is what most of our users do. We figure out where's the NeuroNode going to go, how much movement do we want to be our switch, set our thresholds, and then save them so that calibration or placement in the morning is very easy. You just put it on your user, hit connect, and the settings are saved and they're good to go. The gear in the middle is how we would adjust our threshold parameters. We have an auto baseline setting, and then you can pause the reading of the graph if you needed to adjust your user. So for instance, I have it on myself, but it's paused right now, so it's not actually doing any reading. So how we create a switch is that we have very unique features that can differentiate between an intentional movement versus an unintentional movement. So the signal on is that green line. So our EMG signal has to get across the green line in order for it to be counted as a switch. The yellow line is the level of activity that needs to be returned in order to create a second switch. So kind of having two thresholds is really what allows us to figure out intentional versus unintentional movement, because there's kind of two thresholds that EMG signal has to get across in order to create a single switch and then a second switch after that initial switch. So if we have users that have a lot of fasciculations or high tone, this would be a really good option for them. So if you look here, this is again EMG signal based upon a contraction. As the blue line gets across the green, that's been our switch. In order to create a switch again, the EMG signal has to get back down below the yellow threshold. So this is a really good example of a nice clean graph. We see changes with the muscle contraction. So what I'll do for you guys now is I'm actually on this system itself. So this is what it would look like in real time. I have it placed again on my wrist associated with a finger flexion. So if I unpause it, here is my EMG signal in live time. You notice the graph is moving. I have my green threshold at the top, my yellow threshold at the bottom. As I flex my finger, you see there's changes on the graph between my activation and my resting. Activation and my resting. So if we were talking about a potential user and we wanted to create a switch site from this movement, I could have a movement as small as these little peaks and create a switch site from that. How I could do that is go into my controller application, lower these threshold values even more. So I'll set them really low, and then I'm going to zoom in on my graph to kind of make that movement look even bigger. And then here we go. So every time you hear a beep, that's essentially me making a selection. So like I said, small movements can be used to detect and make a switch site. We have very quickly, we have two modes of setting the threshold. This is where the settings stay consistent throughout the day, but I'll show you very quickly, we have a mode called dynamic where these thresholds are going to automatically adjust based upon the user's activation level and fatigue level. So if the graph starts to notice that they have less movement, it's going to automatically adjust those thresholds. So as I'm resting, my threshold values come down. As I go and move higher, then my threshold values are going to raise over time. So again, this is just one example of creating a switch site in our EMG mode. That sound you hear is just the audio feedback that I've made my switch. My EMG signal has gotten to the point or I've made enough movement to create a switch or selection. You can turn that off, and we do have a visual feedback option as well. So I'll jump right back to my slideshow and show you, let me turn my subtitles on. I'll also show you guys the addition of spatial. So I actually do this activation a little bit more with the pediatric population because EMG is going to register a muscle contraction. So the user has to actually contract their muscle, whereas spatial registers just a movement. And so it's a little bit better because it doesn't need to be on the skin. A lot of our littles maybe have some tactile defensiveness. They don't want something directly on the body, where we could put the NeuroNode over clothes, over shoes, and it'll just pick up a movement. From a therapeutic standpoint, working with that motor plan, I can do a lot of hand over hand to kind of get them going and facilitating what the motor plan is going to be. So I've been doing spatial a lot with the pediatric population. So how it differs from EMG is that the NeuroNode is placed on a part of the body that registers voluntary movement. You want it placed on a point of maximal deflection, and the movement is captured instantaneously by sensors, and it's broadcasted as a graph of activity, just like our EMG graph. The graph is presented in the same format as EMG. Our units are just changing from microvolts to Gs. So here's how we would kind of create a switch in our spatial mode. You look at our three axes of movement, X, Y, Z, our side to side, front and back, up and down. What we want to do is we want to figure out what plane of movement is going to be specified for our user to create a switch site. And then we're going to turn off the reading of the other two to make it a little bit more sensitive. What we want it to do is require a minimum amount of effort while filtering out the activity that's not intended as a switch. So again, I want to reiterate, our main goal here is to not fatigue our users. We're hoping to have minimal movement to create a switch site that they can sustain throughout the day. So if we look at, this is what it would look like on our graph, on our controller application, and I'll show you guys in real time. So we go into Spatial Settings and we're going to turn on the reading of all three of our planes. We're trying to figure out what plane are we going to use to create a switch. So we have our X, our Y, and our Z, and then we are going to turn on the reading of all three of these planes. And this is what it would look like on our graph. So if we pay attention to the top three colors at the top, those are our three axes. My movement here is a toe tap. So I had the NeuroNode just wrapped around my shoe and I was just very minimally tapping my toe. If we see that red line at the top, it kind of mirrors the blue line, which is my movement, and it also has the most variability than the other two. So that's the axes that we're going to select to create a switch, and I'm going to turn off the reading of the other two. So if you see here, this is what it would look like once I've turned off the reading of the other two axes. My blue line, same movement, but we have a little bit more variability and a little bit more room to kind of play with creating our switch. Again, it's going to be much more sensitive to the movement in the plane that we want to try to target. So for example, I'll jump in here and turn on spatial. I'm going to cheat because I already know I'm limited on time and I already know what my defined axis is. But for spatial here, I'm just going to do a simple wrist rotation as my switch site. And I'm actually going to raise my thresholds just a little bit. Okay, so as hold on, let me make sure my spatial control is turned on. My coordinate there. So as I rotate, you'll notice there's changes here on the graph. I'll probably lower my thresholds again to make it more sensitive. There. So I'm rotating, and this would be my switch. But if I move front to back or in an opposite plane of what's targeted, you'll notice that blue line doesn't come up nearly as much as if I do my rotational plane. Same thing if I move up and down. That blue line stays below the thresholds. So the goal of spatial is we want our users to be able to have movement, but we want it to be very specified to the movement that we're trying to pick up to create a switch. So again, spatial can kind of go anywhere on the body. It just registers a movement. Here are some common spatial and EMG placement sites. So if we're going to do EMG, you can do a finger flexion, finger extension, a bicep curl, a tricep push, calf raise, toe point, or shoulder elevation. If we're going to look at spatial placement site, you could put it anywhere around the foot, around the toe, put it on the knee. You can do an ankle rotation, put it around the fingers where it can measure wriggling of fingers. And then for a lot of my students, we actually do spatial on the head, where we're mimicking using a head switch. We just have them wear a headband and we can read and highlight if we want them to do more of a rotational head movement or a head nod, and specify that as an activation site as well. So that's been a more popular placement site since we've added spatial to our list of offerings. So how would you know if you would want to do an EMG placement site versus a spatial placement site for a potential user? EMG is someone who's going to present with minimal movement. So again, we're trying to pick up on small controlled movements that we can create a switch, and that EMG technology can pick up on those small muscle contractions. If someone fatigues really easily, then maybe EMG is a better placement site for them because we can detect small movements. If they only have facial movement, like I mentioned before, an eyebrow raise or a smile, can't really do spatial with those movements, so we would default to EMG. And if they have a consistent activation of a single muscle, then EMG would be a good option for them. Spatial is really good for someone who maybe has a variable EMG signal. For instance, they have a lot of high tone. That is going to be picked up on our graph. We do have ways of filtering that out, but depending upon how they present, spatial might be a better option for them. If they have some tactile defensiveness, because it can go over clothes, over shoes, and not directly on the skin. If they have a lot of fasciculations, again, that's going to be picked up on our EMG graph. So maybe we can find a spatial placement site that would be better suited for them. If they have tremors, depending upon how they tremor, within spatial, the goal would be to filter out that unintentional movement or the tremor. And then if they can move in a plane that's opposite of the tremor, then we can pick that up while filtering out the tremors. And then also if they have really good head control, because we've been doing spatial on the head as an activation here. Yep, I'm about to go into the question if it can be used for communication. Yes, so here I'm actually on our Trilogy system right now. So what the Trilogy system does is it combines the NeuroNode with eye gaze and also a communication software. So we do use Grid 3, but you are open to other communication softwares if you want. So we call it the Trilogy because we say you have 3 access methods in one device. It acts as a regular eye gaze system. Dwell or blink is going to be your activation. But then we also have another mode that is the Trilogy mode that combines eye gaze plus NeuroNode activation. So it's much quicker than traditional eye gaze. Or you can use traditional switch scanning. So for our users who we know do really well with eye gaze, but maybe they have a hard time sustaining it throughout the day, the Trilogy might be a really good option for them because they can start with traditional eye gaze and then end the day with switch scanning or the Trilogy method, whatever kind of works for them. So this is a complete comprehensive system. As far as our system offerings, we have the Trilogy, which is the eye gaze window system. And then we have our NeuroNode Complete system, which is an iOS or iPad product with the communication software of their choice and the NeuroNode. That both options are offered and fundable through insurance. And you guys, I'll have my contact information if you want more specific information on funding. So here's a picture of our Trilogy system. It's very lightweight. Total system weight is 5 pounds. And then to the left is a little NeuroNode carrying case that comes with it. So you have your NeuroNode, your charging base, a band, and the watch bezel. So we say with our Trilogy system, our users have faster speed, less fatigue, and very flexible to accommodate a wide variety of needs as far as access goes. So like I mentioned, it's a Surface Pro tablet. We have a TM5 mini eye gaze camera, Grid 3 communication software, and you have 3 access methods in one system. It's very lightweight. Total weight is 5 pounds. So what I'll do really quickly is I'm actually going to jump it back into EMG mode and I'll just demonstrate the Trilogy activation. So I'm going to be using eye gaze plus NeuroNode so you can kind of see how much speed the user is able to get, because that's a little bit more unique to us. Like I mentioned before, this acts as any other eye gaze system. So if your user does really well with dwell or blink, this is still a good option for them because you do have those options for activation. So let me just jump it right back to EMG because I can move a little bit quicker with my finger. So here is our communication software Grid 3. We have it based upon 3 profiles based upon your access method. So you could do regular eye control, just NeuroNode, you could do single switch scanning or 2 switch scanning, and then also the Trilogy mode, which I'll demonstrate here. So I'll just go into SuperCore really quickly. So traditional eye gaze, you kind of have to either hold the dwell, or you have to blink to activate. Whereas with the Trilogy method, as soon as I have my gaze, I can, and facilitate whatever my NeuroNode movement is, I can activate my communication system. Same thing if you want to use it for computer controls. We do have some users in New York City who use it in the classroom with the iOS, and it registers with the iOS switch scan settings. Cannot use eye gaze with an Apple product, but just really quickly to show you how fast our Trilogy method is. It's much faster than traditional eye gaze. Internal testing, we found that with traditional dwell, it was 133% faster than your traditional dwell. So if you did have a user who wanted to jump from eye gaze into scanning, you would just open up another profile, which we've kind of already created for you here. And then here is just how I have it set to single switch scanning at the moment, but you do have a couple of 2-switch scanning options as well, if that would be something that you were interested in. So very quickly, let me pause this. I'll jump back to the PowerPoint. I want to make sure I stay right on time. Very quickly about Grid 3 communication software, you have lots of interactive learning options, lots of symbol-based communication options as well. SuperCore was the one that I demonstrated where you have different options for core words. But then you also have Pod is really popular, and you do have full computer controls, environmental controls. Maybe if you have a teenager or a higher, more advanced user, you can hook up a cell phone, email, there's social media, grid sets that they can kind of control and use. Also Spotify, that's been really popular. So lots of different options kind of with our system. Very quickly, here's my contact information. So a little bit about what I do. I am a speech pathologist. I travel, before all this, I travel around to different schools, clinics, homes to do assessments. My job is to figure out where the NeuroNode has to go on a user. Right now, the NeuroNode is offered as a comprehensive package with one of our either Windows or iOS based systems. Like I said, we have been fundable through school districts as well as insurance funding, and would work with the speech pathologist if we were going to look at insurance funding and help them write the report or anything like that. We do provide 24-hour IT support to our users. So if there's any issues with the NeuroNode itself, with the software, with the hardware, we provide comprehensive IT support as well as training and implementation on its use. So if you have a student or a potential user that you think would be a good fit for the system, feel free to email me, and I'd be happy to coordinate something with you or answer any other specific questions that you guys may have. Usually I have a little bit more time to kind of present, so I kind of did a very quick overview of the system. But I'd be more than happy to answer any questions that you may have. Oh, the price. So the iOS system with the NeuroNode and a year supply of Electrodes is $13,500. The eye gaze system is $16,500. But thank you so much for attending this morning, and I hope you guys have a great rest of the day, and hoping to connect with you guys soon. If there's no other questions, let me just stop the share here. I have one more question. You're welcome. Thanks, guys. I hope you enjoy the rest of the day.